So I am Carl Moberg. I am the CTO at Avassa, and I have with me today here Fredrik Jansson, who will be doing the demoing down the line here. So we are Avassa. We provide an application management and operations platform for the on-site edge. So this means that we help enterprises, we are happy to call some of them customers, to manage both the infrastructure and allow them to run applications outside of the cloud, which is generally how many of our users kind of define the edge. On distributed infrastructure, of course, in an automated, secure, and scalable fashion, And by on-site edge, and I'm trying to illustrate here, we mean locations where our users put a small number of computers, but in very many locations, and they put applications there that for some reason runs better, close to data sources or close to humans. So this is a very common pattern across a number of industries. I know you guys have seen other vendors in this space, so I won't repeat what they said, but of course we see a lot of traction in environments like retail, where the stores are becoming digitalized, industrial manufacturing, where they put computers on the factory floor, and more maybe exotic environments like in the marine business, where the ships are becoming kind of powerful mini data centers for various reasons. And I just wanted to give you a chance to understand maybe the architecture of our system, because I'm going to talk about a couple of things that we have observed over the couple of years that we've been on the market, and a couple of things that keep coming up with our customers and that we think makes maybe our observations and our features a little unique. But just to give you a brief flyover, maybe some of you have seen our previous presentations, we have two software components. We're a software-only company. We have a central component, which is called the control tower, and that's where this demo, for example, will happen. Usually our customers consume that as a service. Some of them require kind of an on-site installation of that, but that's where all the interaction with the outer world happens, so to speak. We're going to use, for the demo later, a combination of a web UI and a command line interface. We also have a set of REST endpoints, because most of our customers, as much as they like onboarding themselves on a system like this using a web UI, they usually have pretty deep automation plans, so they go towards integrating maybe their CI/CD pipelines and day two operation stacks using the REST APIs and other means. The second component, which we've kind of illustrated here with the little E-blobs on the right side, is something we call the Edge Enforcer. It is a tiny agent. By modern means, it's super tiny. It's about 150 megs. So it's actually a containerized application. So our customers pick their favorite hardware. We're going to show you again a couple of demonstration setups here using, for example, one of our partners on Logic and their hardware. They pick their favorite Linux, usually two camps. One camp that really loves one of the commercial distributions because they need the services and the support and the CVE tracking. But many people also tend to want to package their own, maybe based on Yocto or something. We have minimal requirements on the Linux operating system, so you can think of things like a somewhat modern kernel. We rely on things like VXLAN and WireGuard. But apart from that, we can run on pretty much anything. And we can run on pretty much any of the kind of server-style hardware, which for our customer base usually means x86 or ARM v7 or later. So they install the Edge Enforcer on top of their favorite hardware and Linux combination. The Edge Enforcer calls home. None of our customers actually allow any sessions to be started from the central point. Everything needs to start from the edge. We call home over MTLS or QUIC, depending on what the customer requires. And the Edge Enforcer tells the control tower a significant amount of, or gives the control tower maybe a significant amount of information about the box it's running on, the physical and virtual resources available. So things like how much RAM, what kind of a box are we running on, is there a GPU, is it sliceable, is there a camera attached, all kinds of things that gives a nice inventory style description of the distributed environment, which is then actually the underpinning of placing applications appropriately, because resource scarcity and for example, the existence of a thing like a GPU or a camera can be a knockout requirement for applications. And when you have enough of these, of course, Edge Enforcers, you can start deploying applications to it. And this is kind of just the outline of the system. And I'll show you, or we'll go through other aspects of how this works in the demo that Fredrik is preparing at this point, just to give you a sense of where we stop and where we start. So software only, usually cloud-based control tower. Customers pick their own hardware, Linux, install our agent, and off you go. All right. So let me take a step back, right? We see users coming from two locations, or maybe two previous positions. We have a lot of customers that have the entirety of their application footprint in the cloud. Some would argue that they over-rotated towards the cloud. So they're slowly figuring out that actually moving parts of our applications, parts of these microservices or application topologies to the edge actually makes sense. Some of our analyst friends love to call that the cloud out model. So they move small parts of their application closer to the camera or closer to the user or closer to the LiDAR, what have you. A big tailwind for this is, of course, inference or AI, generally speaking, because you want to do data. You want to look at the data early and not backhaul all of that to your cloud footprint. So a very, very common pattern. Why they are looking to actually use, in this case, we're going to talk about containers. Why they're looking at using containers is because they already have an IT operations stack, an organization, and talent that are all trained on and kind of in love with the container paradigm. And we, interestingly enough, see kind of the reverse or the opposite, which is something some people call IoT in. So you have companies that have had a, let's call it a very stovepipey architecture. This is very common in the industrial environment, that are looking to almost pry loose the applications from the infrastructure because they want to get out of the lock-in effects of many of the industrial kind of companies. Some people talk about this in the kind of IT, OT coming together and all sorts of terms. Kind of technically what that means is that most of our users are looking to use more open platforms like Linux and reuse whatever competence they have around about IT style management. And of course, the end goal here is to go faster and go cheaper.
Carl, what's your take on the time frame for this paradigm shift?
I used to work with AT&T as a service provider person, and I thought I had seen conservative and slow. That's before I met the IoT world, the industrial world. So glacial, I'd say 5 to 10 years. Very interesting enough, if we tease apart the ISVs, meaning the people that want to sell to the manufacturing party, they go pretty fast. It's the manufacturing party that goes a little slow. Yeah. And also, just like in many other industries, some of the bigger companies have their claws very deep into the operations, right? So it's even if you want to, it's hard to get out of what you have in place. But the willingness is growing, and I've been going to a lot of automation and industry events, and there's always a enthusiasm around the concept. Thank you. That's great. The first question. Thank you. Appreciate that. All right. But okay, container seems to work. You know, it seems to actually fit both paths. But there's always that guy. This person you will meet over and over again today. We love him because he represents both an agent of not change and an agent of maybe too sudden a change. In this case, he represents a very common pattern that we see in both industrial environments and actually retail, which is that he represents one of the few applications you simply can't get rid of because it runs on Windows. And that drives the need for virtual machines. So as much as you want to, he actually represents something foundational, something important. He doesn't mean bad. It's just that it's really, really hard to get rid of. And again, there are many reasons. We see things like integration with exotic external hardware. Just the fact that the integration with the central component is hard to pry loose with more modern software, right? So again, you know, he may want to, but he may not want to, but he represents the need to actually run VMs on your edge environment for a little more. And the challenge here now is to see what can we do for him? Because again, this is a very, very common pattern. What can we do to kind of catch and not, you know, leave the straggler behind, but actually kind of keep him with us? I don't want to write too much on your nose, but I will say this. There is a difference, of course, between virtual machines and containers in the packaging and abstraction format. But for us, what's been more important is what's on the right side. What's really powerful for a company like us building a platform like the one we're showing you is not so much that containers are neat tar-based files that can package all kinds of things in it, but more so that it's an industry-wide standard. So we can pick our runtime. And it's an industry-wide standard, not just for starting and stopping things. It's an industry-wide standard for fetching things, for pushing things, for versioning things, for monitoring things, for upgrading things, for a number of operational stuff above and beyond just a means of packaging an application, starting and stopping it. And of course, you guys know this, that drove the whole shape of the paradigm that we now call microservices, right? You can literally ignore much of what you used to have to take into account when you build your applications. So with this in mind, we have a good starting point for a system that is able to manage all kinds of applications, but still in a container-first way. Because our customers usually start with a first application. This is what it means to them, right? Something that drives them towards pushing stuff to the edge. And that, to their defense, is usually some sort of native container application. Again, we see a lot of inference applications, a lot of applications reading from a camera, doing something, and then sending a result back. And if you look at any new vendor today, they will ship by default in a container format. That's how they will deliver their software to their customers. And by applying some clever features to this, we will actually be able to do this. We will be able to cater to that guy and his foundational Windows application while he's trying to find a way to convert out of that legacy setup. And again, examples for this can be, traditional point of sale systems. There's a lot of OT applications that have very exotic requirements on the hardware. So it's a very, very common pattern. The cool thing here then is that the container ecosystem allows us to actually pull them with us. And we're going to show you how that works. So we got great coverage for that guy, and we can support stragglers like him. But it also turns out, which is really interesting, that some of the more forward-looking paradigms in computing this far seems to fit very nicely into the container ecosystem as well. I've yet to find, for example, any ML ops companies, machine learning operations ops companies, that doesn't actually ship their models or suggest the lifecycle of their models using containers. There's some very, very clever details in the container packaging format that allows you to isolate what's called layers, and that's where you put your models, so you can do delta-based updates of the models. So there's a whole lot of neat hook-ins to their needs here. And of course, we have a lot of people talking about WebAssembly. And if you look at the way most of the WebAssembly tooling today works, the output actually becomes containerized. So it's a very, very nice way, too, of shipping the resulting manifestations of any WASM compiler. So it also gives people that want to have some sort of a little more forward-looking plan here, which is most of the CXOs, a way of saying we will be able to support whatever's coming down the pipe or down the line here. So we got a nice little coverage both back and forth. But, okay, so let's look at the matter at hand here. We want to support that guy and his VM, but we want to do that using a container approach. So the way this actually works is that the container image file format uses something called MIME types, which is a standard way of expressing whatever's in it, so to speak. And lo and behold, you can express that this image file actually contains a VM image, depending on which, you can pick any of the file formats, I'm sure previous speakers have talked about here. And you ship that together with a little start script in your container image, and your container runtime will make sure to start this image using the start script, usually on KVM, which is a pretty default virtual machine monitor for Linux. So it's a very, very neat way of saying we can actually ship the container image using whatever tooling we have, the whole system in place with testing and signing and all those kinds of things. But inside of the container image is a VM image. And it doesn't actually stop there. We can also reuse other aspects of the system. So, for example, health probes. The nice thing with the container ecosystem driven by Docker and Kubernetes is that there is a fairly well understood set of probes to query an application, whether it's alive, whether it's healthy, and whether it's actually kind of working as expected. And a really neat thing here is that we can reuse all of that, even for that guy's VMs. So it gives us a very, very nice way of saying we can repackage your VM as a container and we'll run it very well on the platform that we have, using KVM and some neat features in the container kind of ecosystem. So that gives us a very comprehensive set of solutions, and we have it all in place. So it's time to do the first switch.
Yes.
To demo.
Oh, before you...
Yes,
Yeah.
while
One
maybe.
quick question.
Yeah.
So the layered updates to the container image is great. Does the same apply to updates to the VM image? I mean, there's a whole set of challenges in there around data persistence inside the image that you don't get with containers.
It is very true. No, that looks like a blob. It looks like
Just a threat blob, and you're going to ship a new one.
Fairly large blob, unfortunately, too.
And you'd expect not to be actually making changes through the container orchestrator, through a Avassa platform, to what's inside that.
So you have to do it on the blob level. I think we'll show you that. So, but it's blob level. There's based on what we know today, and this would actually, it's a kind of neat idea. Are you in for some standardization work? Because that may be exposing the insides of the VM image format through.
And doing volume mounts to it, so you could actually just trash it and
I mean, we've done other things that are pretty neat around this, because the images are large, and if you fail a common file transfer, you have to restart. So we've actually implemented restartable layer download,
transfer,
but that doesn't cut straight to what you're saying. It's a different thing.
Carl, are you service mesh agnostic?
Say again?
Are you service mesh agnostic?
We actually ship with an internal service mesh, so we run on the container runtime, no Kubernetes. So we use VXLAN and WireGuard for the inter and intra app and inter-tenancy communication. So no need, if you like, for a service mesh. So the demo setup, we're going to be a very large energy corporation. The cluster in the image here is actually the cluster, then it represents the cluster that we have in front. On the little demo card here, and again, one of the hosts here is from our partner, OnLogic. It's going to play a role for the rest of the demo here. And remember that guy, of course, he is central to this demo because he owns this key application that we're gonna put into the system, or actually look at in the system. And the reason why it's so important is that this application that he has is related to authentication and authorization. And it's something that's, for this large energy corporation, we need at the edge. So you have to consider the fact that we love him. It's a very important application, and we'll look at how we can help him.
Yes, sir.
Yeah.
Let's do it.
Let's do it.
So one more thing before we start. So when I'm at this computer, I'm using our control tower, our central piece of software that you use to centrally manage all these locations that we have. Then I'm going to head over to this computer, which is actually hooked up to the network of this particular cluster. So imagine this computer being at this location where this cluster would reside with this customer. So just to give you an overview of what our system does. So this is the control tower, a central piece that we typically cloud host for all our customers. This is the landing page, the dashboard, where you see I'm running a couple of applications, authentication service, and so forth. We have about 10,000 sites. So sites in our lingo is one or more computers in a location where you want to run your applications. So this just gives me an overview of what's happening in the system. You can see that it says error 5. That means out of those 10,000 sites that I have, 5 of those are for some reason down at the moment. Maybe the power went, or maybe a hard drive crashed. I don't know. We're not going to deep dive on this. We also have 10 sites that are disconnected, and that's going to play a larger role later. But in our system, and for many of our customers, the network connectivity will come and go. Maybe they can be offline for weeks at a time in certain occasions. Other customers think that if they go offline, that is a problem, but our system handles that. That is not a big thing to us. Hence, we do them in like light gray, just telling, we haven't seen this guy for a while. Last time we saw them, everything was good. So now I'm going to go to sites here. And so this is where you get an overview of all your sites, but we're going to zoom in on this particular one called Santa Clara. So this is the overview of that particular cluster. So you can see we have 3 hosts. If I click one of them, we can actually see that this is the OnLogic one. I see that on the board vendor. So each of these has our software called the Edge Enforcer installed. It is called home. They have been configured to form this site cluster. As part of that call home, they report information about themselves. So what type of computer am I? How much memory do I have? Am I an x86 or an ARM computer? Then we continuously monitor them. If I scroll up here, what is the memory consumption? What is the CPU consumption? And so forth. The basic things that would affect your application in a bad way. Should you run out of memory? Well, that's going to affect your applications for certain. So that type of monitoring we do for each of these. Very good. That's all I plan to say around the infrastructure. So a number of computers in a location, we call a site, we do monitoring of those, and we later place applications on those sites. So let's go to those applications. So that guy had this legacy application, which turns out to be a Windows-based Active Directory application that he needs, or this company needs, to do authentication. So this is the authentication service, which has been deployed to about 50 sites here in California to do their evaluation of that software. Then they have a company-specific application that they call the grid controller. So this is where someone at the site would log in and check status of the grid, to maybe do certain stuff, look at metrics and so forth. And to be able to do that, they need an authentication service to log into that. But let's start looking at this guy. So this is deployed to Santa Clara among those 50 other sites. I've zoomed in on this guy. And as Carl mentioned, so if I click here, for example, I can see that this is a virtual machine. We are currently running it on this computer, which is called Santa Clara 1. And if I click again here, we can see the probes that Carl mentioned, that this virtual machine, it's up and running. We never had to restart it for any reason. And the reason for that is the probes that we continuously run are returning success. We continuously monitor this VM. If I go to virtual machines here, I can actually click on this guy and open a VNC tab. Click at the click. And that should bring me into this installation, which turns out to be a Windows XP, where not only installing Active Directory, I guess they're playing Minesweeper.
That guy's busy.
Yeah, I'm not sure it's that guy though. I think it's someone. Maybe it's me. Oh, well. Yeah, I'm pretty good at Minesweeper. So this is the virtual machine. As you can see, you can get access to it. You can do stuff with it. You can run RDP to it if you need to do that. I'm going to close this guy. And then I'm going to head over to this one and just show you what it looks like. So again, this application, we have actually deployed one instance per machine here. And they're exposed to the net. And I'm actually going to go to this guy. So can you see this all right? There won't be any, just on the, so this is the grid controller for a very large energy corporation. So now if I log in here, click log in, I get to a dashboard. I can see that I've been logged in using Active Directory. There is not much to do here. Homer is, I don't know, monitoring some index and performance stuff. But just to show that how this works. So now time passes on. They are super happy with the Windows service, but now they actually want to move on. They found this Keycloak containerized application, so they're going to replace the authentication of the Windows-based Active Directory service with a container-based one. So this may happen a year in the future or 10 years in the future, or for some companies, never. They're going to stick with Windows forever, I guess. But we're going to do an upgrade. So I'm going to go to the authentication service. I'm going to make a copy of some code here. I'm going to edit this one. So what I'll do now is I'm going to replace this without going into any details, but instead of running a virtual machine, we're now going to run a container-based, a key cloak in particular. So nothing much happens here. We're going to download the latest key cloak image. That's going to take a short while. Then I'm going to go to my deployment, edit this guy. And here I'll just stop for a second. So here I'm going to tell the system, I now want to run version 2.0 on all those California sites. And I'm going to use this cluster as a Canary site. So when we do the upgrade, let me get rid of that. We're going to start rolling it out to this cluster. If everything is good, we can continue to roll out the container to the rest of the clusters that we have on the sites.
Is this set of changes going into some version control internally inside, so I can see when those changes occurred? And
typically, we recommend our customers to version control these types of payloads. So for the application itself, the deployment itself, because that allows them to, in their CI/CD pipeline, build images, test them, upgrade the application specs, as we call these, and the deployment specs, and send them through APIs through their CI/CD pipeline.
So if you're not explicitly versioning it in here, is there a way to lock people on admission control in here? You can only run this through the CI/CD pipeline to make these changes rather than allowing this.
Typically, yes,
clicking.
Absolutely. That's our recommendation, and actually most of our customers take us up on that recommendation.
And the lifecycle can reside in two places, to be more specific. As you can see here on the application version and deployment history, we do track.
Yeah.
So if they want to use the fact that we track it backwards, the deltas, they can use that. Some of them have moved that feature into their CI/CD. So it's totally up to them. Usually they start here and they move to.
I'd kind of like to have multiple places where I'm certain of, of how the configuration has gone.
Well, question on that, is that because you're expecting two different personas running that, right? This is more infrastructure persona versus application persona?
Yes. So we didn't dig into what we call the application spec, but into that specification goes, so what images, what secrets do I need, what kind of networking, what kind of volumes? That is typically something the application guys know. And then to your point, the infrastructure team or someone responsible for deploying that application to all these locations will probably manage the deployment spec. And that's why we keep them separate. So I'm going to conclude this one real quick here. Just going to show you. So now we're up and running in Santa Clara version 2.0. I'm just going to go back here and log in again. And you don't see much of a difference, but now we actually logged in using Keycloak. So just a way of replacing one authentication service with something else. I'm going to go back, finish up here by saying everything is good, continue deployment. This tells our system that Canary was fine. Please roll out version 2.0 to all the rest of the sites.
Radu, do you have a topology map, an application topology map?
Yes and no. In what I call the application specification, you can definitely describe, these are my services, these are all my containers, here is how they fit together. So you can describe a topology in that sense. Did that answer your question?
No, so you don't actually have a visualization of a topology of your application with all the edge nodes, and then you can just drill down because they say this one's down or whatever it is?
I would say we do. So if let me clear the filter here. If this is what you're looking for, so
no, graphical representation of the application.
No, not of the application itself.
Because that'd be great if you had that as well. Because you have all the information, create a topology map out of it, then you can just see graphically exactly how it's running.
Yep, fair. Yeah, good point. So, I mean, in general, we have two types of users. We have one that will never leave YAML, so they don't want that. But then we have ClickOps people, particularly in the industrial environments. And you're right, that we don't have that feature to take that operational state and render it into a typically a graph.
But it's on your roadmap, right?
That is now it is, right? Yes. I'm not even the product owner, so that's cheap. So here's what I want to leave you with, of course. We definitely see, even if I discount for bias, that containerization is rampant or permeating the industry. People have very few other suggestions on a universal packaging format. And again, the container ecosystem is so much more than just a file format, right? So much more. And as we've hopefully showed you, it's fascinating to see how leveraging some of the containerization features, we can provide a very smooth migration path for people that are more or less stuck with virtual machine-based applications by some clever trickery. And like Fredrik said, that guy will be here and will be around for a long time. And he means well, so it's not a problem. He usually has a business-critical application. And we need a way to support that.
The foundational technology for running the VMs there presumably is KubeVirt underneath, and you're just making, like always, assembling together these external open source tools to something richer.
So we need to be much more lean operational and resource-wise, so we can't afford any Kubernetes here. So
Right.
It's literally Docker or Podman, and then KVM, which is part of the kernel.
So that startup script is directly talking to KVM. There's no other.
Straight into KVM.
Yep.
Yeah.
But I mean, and to be clear, there's not. You've got the concept of taking a virtual machine, putting it on top of a virtualized hypervisor inside of a container. Is there the next step there that I missed of like discovering the applications within that virtual machine and saying, here's how I know now take those applications and abstract them? Or is it just...
So what usually happens is that they go almost binary from a Windows-based application into a native Linux application. So what we showed here was how to go from Windows Active Directory to a Linux native application called Keycloak.
Okay.
So more actually not picking things out of the VM and allowing them to survive, but doing it more of a pure switcheroo.
Okay.
Particularly when you're starting from a Windows machine where you can't run those containers on Linux without a virtualization stack.
Yeah, that. Oh, go ahead.
I remember the lack of Kubernetes support was a discussion point the last time you were at Edgefield Day. I'm wondering if you've seen any friction with your customers on this topic, or are they very much embracing Docker and are moving on with you?
To be fair, as you can imagine, as a vendor, people that are hell-bent on trying to use Kubernetes with the edge don't pay too much attention to us. We see a massive uptake in people that do take an interest in running straight onto the container runtime.
Thank you.
For sure, particularly in what some people call like far edge or leaf edge. And we see that with the hyperscalers too, like they're abandoning Kubernetes for the furthest edge, right? But as soon as you get into something that resembles a data center, and we had this conversation, Kubernetes makes a lot of sense. As soon as it's, this amount of data, the amount of compute you have works really well with that abstraction, it's awesome. It's when you get into the way smaller environments where it gets hard.
Thank you.
I mean, I guess kind of like going back to the same thing I was asking, maybe asking a different way. So for our beloved boomer Windows admin, who was lost and unfound, he's now lifted and shifted his Active Directory controller into a container, and you want him to go to Keycloak. Is there like an Avassa Clippy that's out there that says, hey, we see you're running Active Directory. Would you like to try Keycloak instead? Like give him guidance on how to make that next step in the transition, or is it?
We can help. We can help with services around that, but there's nothing magical, no feature to discover that kind of.
Okay.
Did I understand you correctly that you actually discover what's out there in the network and the configurations, and then based on the configuration, you can determine which applications can actually be deployed to which device?
That's fair to say. So what we do is that when we start the agent on a box, we do a lot of clever things that Linux allows you to do. You look at subsystems like what's called DMI, SMBIOS, and UDEV, and you will get a very detailed view of what this box consists of, both physically and virtually. We package that together in a tree-structured hierarchy, and we expose that to the control tower. What happens then is that people that comes bearing applications can express requirements. They can say things like, this application needs a camera, right? Otherwise, there's no point. It needs a GPU, otherwise it will never do anything smart. So they can use that as an expression to say, only run this in, North America, and only on boxes that meets these requirements. Because that is what our customers do anyway, even before they meet us. They never run all applications with the same configuration in all locations at the same time. What they used to do was Excel. And those Excel sheets have degraded over time, just like any offline inventory. So what we offer is more like an online inventory that you can match against, both on configured things like where things are, but also on physical or operational things.
And how do you deploy the agent?
Huh?
How do you deploy the agent?
So customers take very strong and different operational culturally suggestions on that. Some of them actually ship it out of the factory. Some of them do it using things like Ansible or scripting. They have very strong opinions on how that should work, and they don't want us to tell them how to do that.